We all know how AI chatbots sometimes go wrong. Instead of getting a helpful answer, the bot confidently tells you something completely wrong, or worse, something that sounds right but isn't true at all. They don't always know when to say, I don't know. Instead, they'll try their best to give an answer, even if that means making one up. Large language models, like ChatGPT, are trained on massive data sets, books, websites, articles, videos, and so forth. Therefore, they only know what's inside those data sets. If you ask something they weren't trained on, the model has no knowledge to pull from. The result is a very generic answer, an answer that's completely made up, also known as hallucination, or an outdated answer, because it doesn't have the most recent information. This is where RAG comes into the picture. RAG, which stands for Retrieval Augmented Generation, patches the knowledge gap of the LLM to generate the right answer to a user's question. So very high level, RAG can be seen as a knowledge patch for the LLM to still provide the correct answer, even though the topic of the question wasn't part of the dataset that the LLM was trained on. But how does this exactly work? That's what we're going to discuss in this video. We're going to see what exactly happens when we RAG an LLM. To understand this, let's look at the following hypothetical scenario. Let's assume we have a company that has specific knowledge that's not part of the public domain. In other words, LLMs haven't been trained on this knowledge, as it's our own private knowledge. Now, we want to make use of LLMs for a customer interaction bot on our website to answer customers' question, but we know that those LLMs don't have our specific knowledge that's required to provide the correct information to our customers. To make this possible, we decide to RAG the LLM. So how should we go about this? We take the following approach. When the chatbot gets a question, it first searches the company's private knowledge base for the most relevant information. Then, it retrieves the specific knowledge fragment that matches the question. Next, it gives the retrieved knowledge to the LLM along with the customer's question. Now, with the right context, the LLM creates an answer that's both accurate and helpful. And finally, the chatbot sends the response back to the customer and everyone's happy. This is the helicopter view of what RAG is. Now let's dive deeper into how this all works and explore some examples that might surprise you. Imagine this. A user asks your company's chatbot a question about one of your products, car insurance. The prompt is, what does the middle tier car insurance cover? The chatbot forwards this question to the company's knowledge base, which happens to be something called a vector database. But what exactly is a vector database, and how does it work? Let's take a quick detour to understand how a vector database represents knowledge. Imagine we have a small collection of 4 words: table, chair, wood, and tree. These words are transformed into numerical representations, called vectors, placed in a multidimensional space. Here's the cool part. Words like table and chair are closer to each other in this space because they're semantically related. They're both pieces of furniture. On the other hand, wood and tree are also related, but in a different way, and their vectors are farther apart from table and chair. You might say, wait, chairs and tables are made of wood, and wood comes from trees, so aren't they all connected? And you'd be right, but those connections are weaker compared to the direct link between chair and table. This is how a vector database measures relationships. The closer the vectors, the stronger the relationship. In essence, a vector database is a mathematical representation of knowledge where semantically related items are closer to each other in a vector space. Now, this is a very simplified example. In reality, vector databases handle millions or even billions of items. They represent knowledge across hundreds of dimensions and can include text, images, videos, and audio files. For instance, your chatbot's vector database might store detailed representations of all your company's policies, product descriptions, and customer interactions. This enables it to retrieve the most relevant information for any given question. One of the most well-known examples of a vector database is Google Search. When you type a query into Google, it doesn't just match your words with keywords on web pages. Instead, Google uses a vector database to understand the meaning behind your query, your intent, and retrieves the most semantically related web pages. This is why Google can deliver incredibly accurate results, even if your search doesn't exactly match the words on the page. It's all about finding meaning, not just matching words. So, to recap, A vector database is a powerful way to represent and organize knowledge. It maps information into a multidimensional space, making it easier to find connections and relationships between concepts. From chatbots to Google search, this technology is transforming how we access and interact with information. Now that we have a basic understanding of vector databases, let's get back to our example. After the chatbot forwards the user's question to the vector database, the database looks at all related items to the question and returns, for example, the 5 most related items. The chatbot now has the user's question and 5 knowledge items from the company's knowledge base. These 5 items serve as a context to the question. The chatbot then forwards the user's question along with the context, the 5 knowledge items, to the LLM. With this additional context, the LLM now has the right information to generate the correct answer to the question. The mid-tier car insurance covers personal injury, liability, and theft is the accurate response that the LLM produces. This answer is given back to the chatbot, which in turn provides it to the user. So, in essence, RAG is the pattern used to augment the knowledge of an LLM to produce correct and accurate information.